Get it.
How you going, guys? Curtis from Cutting Edge Engineering. Today's job we got something a little bit different. We're going to be making an adapter plate to go on a drive coupling from a transmission dyno. What a transmission dyno is used for, it's used for testing transmissions after they've been rebuilt, so they can make sure that everything is working correctly, it is selecting its gears right, and all the hydraulic pressures are right, and it can transmit a lot of power. This dyno is actually used for heavy earth moving equipment. They even use it for their 797 dump trucks, which is the biggest dump truck that Caterpillar makes. So I have seen this dyno in person, and it is a very sizable machine. It is bigger than my lathe. So what the customer has given me is the original drive coupling off the dyno and a flex plate that suits the transmission found in the 16M series graders. So what the flex plate actually does, it transfers power from the engine through the transmission. So the way the flex plates work is the center hub works independently of the outer flex plate. As the power is being transmitted through it, it allows movement and it will collapse the springs. And what the springs do is they allow a bit of shock absorption between the engine and the transmission, so all that power doesn't get driven through the transmission and blow it apart. As you can see, there is an internal spline that is exclusive to this style of gearbox. That is what we really need to utilize out of this flex plate. So I will end up pulling this completely apart and machining it, and it will look nothing like it does now. So what I need to do first is get all of this apart. So the customer bought this in second hand for the sole purpose of us turning it into a drive coupling. As you can see, the springs are all loose, so they have done their work. This would need to be rebuilt if it was to go back into service, but today we're going to be cutting it up. So that's pretty simple. Undo 12 bolts and the whole assembly comes apart. So these flex plates, they do have 12 double spring systems in them. The reason for that is the amount of power and the amount of torque these engines can exert is very high. In a standard car, you would find flex plates that would have maybe 4 springs in them. Some of them would have doubles. Trucks are obviously a high output power sort of application, so they'd have a very similar flex plate. But something else they've started to do is flex plates with springs aren't a thing anymore. They make them solid. They're called a dual mass flywheel, and they have the springs in them. The problem with the dual mass flywheel, they are difficult to grind them back to a nice surface finish when you put in a new clutch because they are spring loaded. So one of the key things to note when you do have a worn out flex plate is when the springs start to rattle, you will know the flex plate is pretty much on its last legs. What happens then is there's that much power getting through there, the springs aren't taking up that shock absorption, and it does end up tearing apart all of the plates that hold everything together, and sooner or later everything just falls apart. So we're just going to bolt back together the parts that we don't need, and then we're going to get on to doing the center hub. So before we set this up in the lathe, I'm going to take it over to the welding area. I'm going to use an angle grinder and cut off all of these spring tabs because that would be a very brutal interrupted cut, and I would more than likely just break inserts. That's nothing, that's just the paint, all the rust on it. Now that that's set up, the first thing I'm going to do is reduce the outside diameter to the same size as the drive coupling. So we've taken our cleanup cut. That plate is extremely hard, but it's not something we can't machine. So we've taken the outside diameter, put it into the DRO, and then we've minused off our finished diameter. Now we've got 65mm to machine off. Right, we're going to ceramics. That is extremely hard. Chip just the tip right there. Now we're through the hard layer. It's going to get nice. So I can tell now we're past the hardened layer on the face. That is because the swarf is much cleaner, it's much sharper, and it's not as brittle as the first layer we took off, and the surface finish is a lot nicer. So I'm going to take out the ceramic, put carbide back in there. Hopefully we'll get the majority of the way through that, because the back side of that is going to be hardened as well. I was going to take that out a bit off. Right, so now we've got the OD turned to size, I'm going to counterbore the ID to suit the spigot on the drive coupling. So I'll be counterboring it 3mm deep and to a diameter of 91.8mm. Righto guys, so that's all the machining done. We're going to take it out of the lathe and set it up on the mill so we can drill some holes.
Really? Wait, where did the ball bit go? Oh, look, what's this? What's that? What happened?
Righto, so I've got that set up in the mill. I have found center, so we are ready to drill our 4 holes. Considering how hard this material is, I'm not even going to try and use a standard high-speed steel drill, but I don't have a 10mm carbide drill to use to suit the hole size. So what I am going to use is a solid carbide 6mm drill to start the holes. Then I'm going to open them up with a 10mm end mill to their finished size. So even though my 10mm carbide end mill is self-drilling, I'm not going to risk trying to push that through a hardened layer of material because the chances are a piece of swarf will get stuck around it and it'll actually move. If it moves in the hole, it can chip the end mill or it can destroy the hole position. So we've successfully drilled our 4 holes. What I need to do next is turn the part over in the mill, and then I need to counterbore the holes. There is a radius there and it won't allow the bolt heads to sit flush when they go to bolt it up. So we're going to give them a nice flat surface there with an end mill, and that'll eliminate all those problems. The reason why I drilled the plate the other way up to start with is because of how hard this material is. Trying to start a drill or an end mill on a radiused edge would force the drill to either walk or break, and because these are precision holes, I couldn't run the risk of the drill walking out of position or breaking an end mill. So I'm just going to use the end mill to locate the hole, tighten the part down, then I'll use a 16mm end mill to then flatten out that radius. So there's one more thing that I need to do, and that is chamfer the holes on both sides. So I'm just going to use an indexable chamfering tool in a battery drill. Righto guys, that's our adapter plate completed. Even though that material was quite hard, it was still a pretty straightforward job. That only took a couple of hours. Now I'm going to get it back to our customer because I know they've got a transmission they want to test. Thanks for watching.
Is that hot?
A little bit. So what we're going to do first, we're going to undo all these bolts and release... Oh, fuck me. So what we're going to do first, we're going to undo all the bolts on the front of the flex... Oh, fuck me, words. So what I'm going to do first is remove all of the flex block... Oh, I can't even get words out. Right, so these...
Ooh, good one. That was good.
Back in the day with our drift cars, we used to run a solid plate clutch, which meant all of the power went directly from the engine through the transmission, and that was how we were able to break traction so quickly. In an earth moving machine, you're not trying to break traction, you are trying to exert the power from the engine through the transmission without damaging anything.
You had to put that in.
I did, yeah.
Well, that was horrific sounding.
I didn't expect it to be that hard. That is extremely hard. God, that feels so fucking weird.
You need this down here. Remove it, please. I hate this on the ground.
It's got to be on the ground. It
Move
can't.
it out of your walkway though. You can put it on the ground behind you. There you go.
I just did, but then yesterday you complained about
It was in the ground in the way. It's
in the
not
ground in the way?
You're in the way. Go. I'm ready.
You're in the way.
Do you want to put the fans on?
Oh, when it suits you. Otherwise, I fucking cook. See, I've adapted to it now. I'm okay. I'm not even sweating.
I have also. I'm not even sweating.
I'm not even sweating. Right, now you just need to get that to size.
What to size? The
Hole. I didn't machine it to size because I'm only machining with ceramics.
Okay, I don't know what you're getting to size.
That hole
Yeah.
to the right diameter to suit that.
Correct. Good job.
Righto guys, so that's our adapter plate. Righto guys, so that's our adapter plate. Did it again. Righto guys, our adapter plate is now. Oh, for fuck's sake.
What happened? George! Hi! It's George! Where is he, homie? Hi? What's that dog doing? George. Let's go.